All right, guys. So in the previous video, we talked about proper loading techniques for a liquid sample in infrared. And we said that they have to be pure compounds. We really shouldn't be running mixtures. And these pure compounds, we would only need one or two drops. That's all that we really require. And those one or two drops get put onto a salt crystal that we have ordered preferably from a manufacturer. So that way they're all consistent and they're the same. We said that these salt crystals are really made of salt, so water we have to watch out for, and the water can start to destroy the salt disk themselves. So we have to make sure there's no water that gets on the crystal. We have to make sure there's no water in our sample. And then we make a salt sandwich with a couple of drops of sample in between, put it on the metal disc, and we put that platform into the sample chamber in order to analyze. Something else that I need to say are that these salt crystals, because they're so water filly and touchy, have to be stored in a desiccator. And a desiccator is just, and you'll see them in our lab, is basically a piece of glass. It's got a big lid, heavy duty lid, and it typically has some kind of round area that you can store things in and a base that sits at the bottom. You'll see probably some blue crystals that are sitting down here at the very bottom of the desiccator. And then on top of those blue crystals, you will see a porcelain platform. We keep our salt crystals on that platform and the lid closed. Uh, these are desiccant crystals, and it absorbs any water that might be in the atmosphere. So it keeps it completely dry. Water cannot venture into this vessel and start to slowly decompose the salt crystals on us. And that's the purpose of those crystals and the desiccator. The crystals have an indicator, so when these change color, then that tells you it's time to put fresh desiccant crystals in them and have them ready to go for the next round of salt crystals that might be stored in the desiccator. Okay, so all salt crystals are stored in a desiccator in our laboratory, and that's where you can find them. Never pull directly up and down on the lid because you will crack it. You have to slide the lid to the left and to the right in order to take the lid off of this thing. Okay? All right. Now let's talk about a solid. Sometimes I've got a solid that I need to analyze. And this is not going to be too big of a problem, but there is an extra one or two steps that are involved in analyzing a solid compound on infrared. First, I still need a salt crystal. So I not only just need one, but I need two. Just like with liquids, there is no difference. The problem is that I'm going to take this solid, and it's probably going to be a powder or a crystal, and I'm going to have to add a compound to it. And this compound is called Nujol, Nujol. And Nujol is just a fancy, expensive mineral oil. It's kind of thick, much thicker than water. The Nujol is very clean. There's hardly any contamination in it. And the Nujol is going to serve as a carrier for our solid crystal. And I mix these two things together and I form a paste. And that paste will then be smeared on the surface of the salt crystal. That's the difference in loading a solid versus a liquid. Okay? So I still need two salt crystals. I'm going to clean them. And this time I'm going to put Nujol on the salt crystal when I blank it. Then I take the salt crystal sandwich out. I take the salt crystals back apart. I mix some of that Nujol with my crystal or my solid. I get a pasty-like material. I smear it on the surface of a salt crystal. I put the sandwich back together, and then I put it back into the metal plate system. That goes into the infrared, and then I run it. So that's one way that we can analyze a solid. Take Nujol, a very pretty, expensive mineral oil, make a paste with the solid that you're wanting to analyze, smear it on the surface of the salt crystal, put the salt crystals in the machine, and analyze them. Another way that we can analyze a solid, and we do not have this method in our laboratory, is a press. And what happens here is that you would take some crystals of your solid and you would take some sodium chloride crystals or potassium bromide crystals, whatever kind of crystal you want to make, traditionally in an infrared salt crystal. You mix the two things together and you put it into a press, which is this basically fancy instrument with a big crank that sits over here to the side, and that crank will take this salt and your solid and it will press it into its own crystal. So you're making your own salt crystals here with a little bit of elbow grease, and these salt crystals will then pop out just like these, and those salt crystals can then be placed into the metal chamber and then analyzed in the infrared spectrometer. So there's two methods of running a solid on an infrared spectrometer using crystals, your traditional loading method. Number one, mix it with Nujol, make a paste, smear it on a salt crystal that's already been ordered for you. Or number two, take your crystal, mix it with the salt, put it into the press, crank the lever, and make your own salt crystal to run on the infrared. The choice is up to you and your employer. For us, we use the Nujol method. Finally, we do have ways that we can analyze a gas. This does not require a salt crystal, though. And the reason it doesn't require a salt crystal is how on Earth are you going to get a salt crystal and have it keep a gas to analyze for you? So, what you will find in a laboratory that has to analyze a gas sample in infrared is something that looks like a polarimeter cell. If you've used our polarimeters before, these types of cells are going to be very familiar to you. And if you've used maybe our longer cuvette cells for the UV vis instruments, these cells are very identical, or very similar at least. So this is a gas cell for an infrared chamber. And what happens is that you will open up one side, you will fill it full of the gas that you want to analyze, and then you close it off. And this is a tight seal, and the gas cannot leak out. You would put this whole sample chamber into the machine, and then you would analyze it just like any other sample before. However, you're probably seeing over here to the side, these things are not very cheap. So you're looking at $500 to $700 a cell, depending on how big you need it and what type of material you want it to be made of. But this is how we would analyze a gas on an infrared spectrometer. Okay, so very similar to pieces that you've seen before, just made a little bit special for the infrared spectrometer. There's many different ones that they will come in. That's just one example. Some of them are glass and you can see through them. Some of them are not and you can't see through those. They are more of a solid chamber like this one. And if you look at the price is a little bit more expensive too. So that's the story with the gas, the solid, and the liquid samples that need to be analyzed on the infrared. You can do all three. It's just, do you have the right utensils to analyze those three? Most of them will come to the form of a liquid. Then, every now and then, you will get a solid. And rarely will you be asked to analyze a gas. We do not make you analyze any gases at all throughout the 2-year time that you're with us. An employer might, but it will be very rare. Okay, so that's one way that we can have a sample chamber to analyze all 3 sets or states of matter. There is another way, though, that we can put samples into the infrared and have the machine analyze them. And that other method is much easier, but that other method is much more expensive. And that's what we'll talk about in the next video.